Hi everybody, this is Mrs. Pearson tonight, woohoo! And what we're going to be doing is using a number line to model the addition of integers. So your objective that hopefully you'll be able to understand by the time you get done with this video is that you'll be able to model integer addition, on a number line given word problems and equations and understand that vectors represent distance and direction. All right, let's start off. If the temperature outside was 2 degrees below zero and it increased by 3 degrees, what is the temperature outside? First thing we need to do is write those statements as numbers. So 2 degrees below zero would be written as what? -2. If it says increased by 3 degrees, this should be written as a +3 or a +3. So to solve the equation, -2 plus 3, we will use vectors on a number line. What is a vector? This is a new word that you'll learn this year. A vector is a line that shows distance and direction. For example, the length of the line tells the distance and the arrow shows the direction. So check out these arrows. The first one, if you see an arrow going to the right, obviously that means to move to the right. If you see an arrow that goes to the left, that means you're going to be moving to the left on the number line. Now we're going to work out a problem using straight arrows called vectors. Here's the same problem that we discussed on the previous slide. It says -2 plus 3. Here's our number line. And the first thing we're going to do is we're going to place the tail of the arrow on 0. This is our starting point. So here it is. Step 2, we're going to draw the arrow moving left 2 units and stop at -2 because we are counting down from 0 2 places. So this is what it will look like as a vector. Here it is. It's going to be an arrow. It's going to the left because we are counting down 2 places. Notice where the arrow ends up. It ends up on the -2. Step 3, we're going to start the next arrow at the end of the first arrow. And that point will be at -2 because that's where the last arrow left off. Step 4 is we're going to draw the second arrow 3 units to the right to count up from -2. So let's go ahead and write that 3 in. And then we're going to go ahead and take a look at that vector. Here it is. Notice that the starting point is at the -2, which is where we left off with the first arrow. And notice that it ends on a +1 because what we're actually doing is we're moving up 1, 2, 3 spaces to the right because it's a +3. Now remember, you are going to see vectors in the future on this unit, but if you still need to draw these bubbles in order to show direction and which way you're going, that's fine too. You can do it either way. Step 5, you're going to stop at the number 1, and that's actually our answer. So -2 plus 3 will equal 1, and I'm going to put that right up here. It equals 1. Okay, let's try some more. We're going to use vectors and a number line to evaluate the expression below. Here we go. 3 plus a -2. Where do we start? Try to remember. What I want you to do is I want you to go ahead, try this on your own by pausing the video and then come back and we'll show you how to do it. Hopefully you paused the video. So now let's look at how we're going to use vectors and the number line to evaluate this expression. First thing we're going to do is we're going to start at 0. And the reason why is that's where we begin all of our number sentences, is at 0. Notice that we move our arrow to the right because it's a +3. Notice that we are actually moving up the number line 3 spaces. 1, 2, 3, because it is a +3. Our next step then is to start our next vector where the previous vector left off. It left off at a +3. Notice that the next vector moves to the left or faces the left side of the number line. The reason why is because it's a -2, and -2 means that we go to the left on the number line. Notice that the distance that my arrow is going is actually 2 spaces. 1, 2. So my vector is showing that I'm going to the left 2 spaces. And here it is all worked out for you. You're going to start at 0, move to the right 3. The vector shows the direction, which is the right, and the distance 3 because it's a positive. And that's what we just discussed. Then you're going to move left 2. The vector shows the direction left and the distance 2 because it is a negative 2. So what will our final answer be? Where does that arrow end up? Our answer is 1 because it ends up right here, lined up with the 1. Now notice this. 3 plus a negative 2 is really the same as what we saw before, negative 2 plus 3. The reason that this is true is because with addition, it doesn't matter which order you put the numbers in. This is known as the commutative property. Hopefully this recalls some of that from 6th grade. I think it's 6th grade. All right, here we go. What if you're given just the number line with vectors? What we want you to do is write an equation that would model the sum of the arrows on the number line below. So let's check out our number line. Notice where our first number line starts. Here it is. It starts at 0, which we know is our starting point. Notice the direction that it moves in. It moves to the right. If it moves to the right, then that means it's a positive number. Our positive number in this case is a 7. So here we go. We got the 7 here. Then where the 7 ends, notice we start our next arrow, which goes to the left. This arrow is actually going to the left 7 spaces. So that means it's a negative 7. Our top arrow starts at that 0 because if we went forward 7 and then went back 7, we end up at 0. So then we begin our next vector at that point and we go to the right. Notice the distance we're moving our vector is 5 spaces. So that's a positive 5. So our answer is 5 because it ends up on the 5. Now let's look at writing this as a number sentence. First we said we went to the right positive 7 because we're going to the right 7 spaces. Notice in our number sentence down below, we have a positive 7 to start. Then we move to the left 7 spaces because our vector is going in the direction of left and it's moving 7 units to the left. Notice in our number sentence we have a negative 7. Then finally, we move to the right 5 because our vector is going to the right and the distance is 5 units. So notice here in our equation, we also have a positive 5. And then our answer is 5 because that's where we ended up. All right, your turn. Time to practice. What I would like you to do is I want you to read this as I read it, and then I want you to go ahead and pause the video at the end of reading it, and I want you to try it on your own. It says, during the football game, Jonas lost 4 yards on the first down. On the second down, he ran for a 3-yard gain. On the third down, Jonas lost 5 yards. How many yards did Jonas gain or lose after the 3 plays? Write an equation and model your answer on the number line below. Go ahead and pause the video, try it on your own, and then come back and check your work. Okay, welcome back. First thing we're going to do, once again, is we're going to start on that 0 because that's where we start all of our vectors. It says Jonas lost 4 yards on the first down. So if I go up here and I look at the word lost 4, that actually means a negative 4. So I'm going to start here at 0 and I'm going to go the distance 4 to the left because my word up here says lost. So there's my vector. I started it at 0. I went to the left 4 because it says I lost 4. Then it says on the second down, he ran for a 3-yard gain. A gain means a positive number. So if it's a 3-yard gain, that means I'm moving forward 3 yards. So I'm now going to go to the right 3. So if I look at my vector for this one, it starts at the negative 4 where my last vector left off, and it moves 3 units or 3 numbers to the right. 1, 2, 3. Once again, if you need to draw bubbles to help you out. On the third down, it says Jonas lost 5 yards. Once again, the word lost means that we are going to go to the left 5. So let's go ahead and start our vector where our last vector left off. There it is. It starts on that -1 and goes 5 to the left. Notice if I count using bubbles, 1, 2, 3, 4, 5, my answer will line up with the -6. Sorry, my bubbles are so sloppy. So now let's write an equation. Well, first, Jonas lost 4 yards, and up here in the number sentence, we wrote down, in the word problem, we wrote down -4, the number -4. So here it is. Then we said he gained 3 yards. So we're going to add 3. Then it says he lost 5 more yards. So I'm going to go ahead and say that he lost 5 more yards. So what will my answer be? Right where my last vector left off, which is a -6. There it is. It matches up with what I just did. Woohoo! I got it right. Okay, let's try the next one. All right, here's a number line. You know what that means. What you're going to do is you're going to draw an equation that will model the sum of the arrows on the number line below. So here's my first arrow. Here's my second arrow. Here's my third arrow. So remember, you're going to start with the first vector, and that starts on 0, and then continue with your equation. So go ahead, pause the video, give it a try, and then come back and check your work. Hopefully you paused the video. Now we're going to check to see if you're correct. Notice this first arrow right here is starting on 0. That's my starting point. So I know I'm going to the right, which means it's a positive number. Notice I'm going 1, 2, 3, 4. 4 to the right is a +4. So I'm just going to go ahead and write a 4. Then I start my next vector where that one left off. Notice it's going to the left. If it's going to the left, that means it's a negative number. And notice how many spaces I'm going to the left. I'm going 1, 2, 3, 4, 5, 6 spaces. So that would be -6. Now notice this. My next and last vector starts on that -2, but it goes to the right. So that means it's a positive number. So notice I'm moving 1 unit to the right, or +1. And if I look where that final vector lines up, and it just went away. I don't know where my vector went. I must have pushed a button. It lines up on a -1. So let's check our work. Oh, there it is. It came back. Yay! There it is. Finally, our focus question. How do vectors determine distance and direction? And what do the vectors represent when working with integers? Go ahead and answer these questions and bring them back with you tomorrow. See you tomorrow.